Good afternoon, students. I hope by the grace of God you are all doing fine. So today's date is what? 6th of May 2020. That's the date. This 6th of May 2020. And our subject for today is what? Native physics. So without wasting much time, let's quickly begin our lesson by performing this experiment. So I have with me a bowl containing water, a metal, and a wood. Let's observe what will happen when we drop them into the water. So first of all, I'm dropping the wood into the water. So I've dropped the wood into the water, and we have all seen what it has happened. Again, I'm dropping the metal into the water too. So I've also dropped it. So we have all seen what it has happened. So based on the experiment, who can tell me what he or she has been observed? So this is the question to the class. Who can tell me what he or she has observed? So let's proceed. I hope we have all seen that the wood has food and the metal has sink. So why is it that the wood is floating and the metal has sink? This is a question to the class. So I believe you are thinking of what? The heaviness of the object. So you can say the wood is what? Less heavier than or as compared to the metal, or the metal is what? Heavier than the wood. So that's good. So in science, you normally say one is what? Denser than the other. So in this case, based on this experiment, we can boldly or confidently say that the metal is denser than the wood. So this leads us to what? Today's topic, density. So the class, a question to you. I said, based on the experiment, or let's quickly write our objective and proceed. So, objective. He said, by the end of the lesson, the student will be able to 1. Define density. 2. Write the formula for calculating density. 3. Explain why certain substance or object float and others sink when placed in water. 'So that's our objective. By the end of this is a lesson. So he said this is the objective that we need to achieve by the end of the lesson. So first of all, we said by the end of the lesson we should be able to 1. Define density, and 2. Write the formula for calculating density, and 3. Explain why certain objects float, while others sink when placed in water. So let's quickly come to our experiment. So from the experiment, based on the experiment, who can explain density? This is a question to the class. Based on the experiment, who can explain density? So from the experiment, said density is simply defined as, or density simply tells us how much mass exists in a given volume. How much mass exists in a given volume. Or density is mass per unit volume of a substance. So that's the definition of density. It's based on the experiment. So that's that. And the symbol of density is what? Rho. So this symbol is normally represented by density. So anytime or anywhere you see this symbol, rho, it means density. And rho, which is what density, is calculated mass over volume. So rho is equal to mass over volume. So I'm using M as what? Mass, and V as what? Volume. So from that, let's quickly see the unit of density. Density normally is measured in kilogram per meters cube. So the unit of density. So this is the unit of density. Density is what? 1. Measured in what? Kilogram per meters cube, or expressed in what? Kilogram per meters cube. And 2, it can also be what? Expressed in what? Gram per centimeters cube, or gram per milliliters. That's the density. So when you get any question and we have 3 of the unknown here, if you don't know density and you have been given mass and volume, so simply I have a diagram on the board. So I just divide this here. So first of all, so on the board you can see the diagram, which is what? The mass M is representing mass, and D here is representing density, and V also representing what? The volume. So if a question is what? Being posed, or a question is being given to you, and let's say you have been given a question and you don't know the density, and they have asked you to find the density, but you know the mass and the volume, you only cover what you are finding. So in this case, you will cover the density so that we can see what it has happened. So density normally is what? Calculated based on what? Mass. So mass is what? On top, and volume is what? Down. So it's what? Mass over volume. So that's how you calculate density. And in case one mass is what? Given, and the density also is given, they ask you to what? Find the volume, you just cover the one that you are about to what? Find. So you see what it has happened. So you can also see that it's what? Volume can be also calculated by what? Dividing the mass by the density. So volume is also what? Mass over the density. Again, if the mass is what? Unknown, and the density is what? Given, and the volume is also given, we quickly find the mass by what? Using this diagram, covering the mass, and you can see that mass is what? Being calculated by what? Multiplying the density by the volume. So this is how, anytime a question is what? Being put to you, that's how you use it to solve. So quickly, let's come to, okay, let me ask if there is any question, you can bring it so that we all discuss. If there is no question, you can proceed. So let's quickly come to our experiment and see why did the wood float and the metal sink? What is the idea behind it? So quickly, so from our experiment we can confidently say that if the density of the object is less than the density of the water, the object will sink. So I'm using rho. We said rho is for representing density. So So that's we are using rho. So I'm using this one as well. If the density of what an object is less than the density of the water, it's equal to what fruit. So it's equal to fruit, meaning if the density of the object is less than the density of the water, the object will float. And again, we all see from the experiment that the metal sinks. So if the density of the object is greater than the density of the water, also is what equal to sink, or the object will sink. That's how we have what put it in simple equation like that. So based on that, maybe your mind is what baffling you that this also have any implication in our life. So let's quickly see applications or uses of density. So any question from what we have learned so far? We are moving on to next topic, which is what application of density. So first of all, who can tell me, based on the experiment, that you can tell me that anything that you have seen that you have based on density, the principle or what we have learned so far in designing it or constructing it. So based on that, uses of density, we can say density is what one uses to what measure or find the compactness of what a particle of a substance or an object. So density normally is what used to find the compactness, how compatible the particles of what an object is. That's why we can normally say that this object is heavier than this, or this one is lesser than this, or less than this. So that's density. We can see. We can use it to measure that. And again, one major important or vital role that density also plays is our transportation by sea or by any river that we can see. So we have all seen how the ships and boat is what being designed. It's all based on the application of density. That's why they have designed in such a way so that they can be able to float on the surface of water. They will be lesser. Their density will be lesser than the density of the water, so that they can float on the surface of water. And again, when you go to our health sector too, you normally apply density there too. When we are evaluating the rate at which blood float in the human artery, we also use density there. So that's the application that I can also say about density. So class, you can, this is your assignment, you can go and find out a lot applications or uses of our density based on that. So what have you learned so far? First of all, we are able to work based on this experiment that we did. We are able to work come out with the meaning of density, and we said density is what? Density tells us how mass exists in a given volume. Or density simply means mass per unit volume of a substance. And we saw that density normally is what represented by rho, and each unit can be what? Kilogram per meters cube, or gram per centimeters cube, or gram per milliliters. And we said if the density of what an object is what less than the density of the water, the object will float. And if the density of the object is what greater than the density of the water, the object will sink. And again, we also look at some principles or some basic phenomena that we can what manipulate to solve any of the unknown, either mass, when we don't know the mass, how to find the mass, when the density is what given and the volume too is what also known. And we represent it by in a diagram form. And finally, we come to what our applications of density. And we said density is what being used to what find how compactness of what a substance is. And two, we said it helps us or it aids us in what our transportation. And three, we said when we are evaluating the rate at which blood flow in the human artery, density 2 is what being applied. So from this, what we have learned so far, I believe you have all get it. If there is any question, you can ask any question that you don't understand, anything that you didn't understand based on what we have done. You can bring any question so that we can all explain. So if there is no question, I said that's the end of the lesson. So thank you for your attention. God bless you. Bye bye.